Hi there, Serdar Gagulop here for InfoWorld at IDG. In this episode of Smart Go, I'm going to give you a quick tour of the basic data types in the Go language and how variable assignments work with them. Now, every language for computing has a set of basic variable types. These are the building blocks out of which other types can be composed. In Go, the basic types ought to be familiar to anyone who has come from a low-level language like C, since many of Go's types are meant to reflect what's available on the hardware of most computer platforms. The most basic data type in a computer is a bit, or a Boolean, as it's called. That's 1 or 0, true or false. So in Go, we have the bool type, which can be either true or false. Up there, we have the integer types. In Go, you have two basic kinds of integers, the signed integer, int, and the unsigned integer, uint. The default size for both of those is whatever the bitness is of the underlying operating system. Typically, that's 64-bit, since most of us are running 64-bit systems at this point. If you want an integer of some specific bitness, you could request an 8, 16, 32, or 64-bit variety of integer just by changing the name. If you need integers that are bigger than what a 64-bit number can hold, Go has a package in its standard library, math/big, that deals with such things. These are what are called arbitrary precision numbers, and that's something worth covering in a separate video, though. For floating point numbers, Go has two built-in types, float32 and float64. There are third-party packages for a float16 type, since there are some data science applications that now make use of that format. But Go's maintainers don't plan to add float16 to the language itself unless there's widespread hardware support for it. Now, Go also has two data types for complex numbers, complex64 and complex128, which are used for float32 and float64 numbers respectively. And you can describe these by way of a function, complex10, 4, or by way of a special addition syntax, 10 plus 4i. Both of these will yield the same value. Go also has a distinct type for holding memory addresses, uint_ptr. This is just an integer which is the size of the underlying platform's bit depth. So for a 64-bit platform, it's 64 bits. It is worth noting that a uint pointer, as it can also be called, is not itself used as a pointer. You can't dereference it and get the contents of memory with it. It's just a number. That means you can perform math on it, which is something that you cannot do with an actual Go pointer. This distinction is something worth going into in another video, but it's useful to know that we have a special type for this sort of thing. Another type in Go that ought to be familiar to people coming from C is the byte type. This is just an alias for an unsigned 8-bit integer. However, unlike in C, there is no char or character type in Go. Finally, on that note, there are two variable types that can be used for dealing with strings, the string type and the rune type. Strings are just immutable text stored as an array of bytes, but runes are individual Unicode code points. They're essentially int32s that are used specifically for working with individual Unicode characters. Again, the way strings and runes work in Go is complex enough that it's worth talking about in another video. Now in Go, every variable that you use has to be declared in some form, but you do have some flexibility with how declarations work. So there's a number of different syntaxes for variable declarations. Now, if, for instance, I just say a equals true, Go's compiler will reject it. Because if I use an equals sign by itself, that just implies that A has already been declared somewhere. So if the compiler can't find that declaration for it, it won't assume anything and it will just refuse to compile the program. So to make this work, we can just say var a bool, and that will explicitly declare the variable. We can also say var a bool equals true, or just var a equals true, since it's unambiguous what type A would be in this case. But we can also use the colon equals operator to declare and assign a variable in one swoop. This is the most compact of the syntaxes that we can use, but it makes the most sense and is the least confusing in contexts where the variable scope is small. For instance, if you're using it in a for loop. That's where this sort of thing is most commonly used anyway. Lastly, one convenient thing about variable declarations, which is that if you declare but don't assign a variable, it always gets set to a sane default. For numbers, that's 0. For booleans, it's false. For strings, it's a 0-length string. This way you don't have to worry about catastrophic consequences if something isn't actually initialized. That's it for this video. If you liked it, please leave a comment below. Don't forget to subscribe to the IDG Check Talk channel on YouTube. And for more Smart Go, be sure to follow us on Facebook, YouTube, and Infoworld.com.